picture here. Another one involving a plane. I'm just going to throw at you some situations here that might be a little bit tricky. Okay, so we're going to do that picture. And I'm going to ask you some intersection questions. And see if you guys, see if you can hang. Can we do it? So, oops, I'm going to have to back that up a little bit. So, what is the intersection of plane ABC and the line AB? Now, line AB, is it piercing the plane like the last one did? No, it's a situation where that line is lying in the plane. Kind of like that, where the pencil is just laying on the piece of paper like that. So remember, the intersection is where the things cross. Okay? Well, cross might not be a good descriptor this time. Think of it this way. An intersection is where the things touch. So where do these two things touch? Yeah. Nope. Yep. Line AB. It's the whole line. Isn't this entire line touching the plane? If it's laying down flat on it like that, right? It's not poking through it. It's laying down on it. So every part of that line is touching the plane. Okay? So the intersection of that plane and that line is the whole line. Okay? So the answer to this question then would be the line AB. All right, let's try another one. About the intersection of plane ABC and plane R. So where did the two planes touch each other? Yeah. You are so close. You got the right idea. Okay, line segment ED. It looks like a line segment, doesn't it? I was real sneaky with this one. It looks like a line segment, right? Think about this for a second, though. Here are my two planes, two pieces of paper. This one extends infinitely in all directions. This extends infinitely in all directions. So if I make two planes come together, it's not a line segment. What is it? It's a what? It's a line, right? Technically, if the planes go on forever, then where they're touching should go on forever too, right? And if that little line segment continues on forever, it's a line. It's not a segment anymore. It's the entire line. So, the answer to this one then is the entire line DE. Okay? All right, got one last one for you here. So the last one, what is the intersection of point C and line AB? Bless you. Yes. Good guess, but no. Remember, intersection. What you did was you found something that both of those two things touched. My question, though, is where do those two things themselves touch? Yeah. They don't. Right? It's kind of a trick question. Be none. They have no intersection. Okay? They're going to try and trick you like that, too, in your homework sometimes. None. Yeah. So if it doesn't look like they're going to touch at all, it's probably the case. Yeah. Okay. So, okay. Let's see. The only other thing I really need to talk with you guys about, and then I'm going to be done chatting here, is the fact 2 points determine a line and 3 points determine a plane. Okay. Why do we need 2 points to name a line? It's a question I get a lot. Okay. Well, the reason is this point, A, and he's stuck on my notebook paper and can't get away. A is right there, and it's not going to move. How many lines could I draw through A? As many as I want, right? A line like this. I could draw a line like this. I could draw a line like this. I mean, an infinite number of them, right? I could keep going. I could keep making more. If instead I made it 2 points on my paper. So here's point A, stuck, can't move. Here's point B, stuck, can't move. Now, how many lines can I draw through both of those points at the same time? There's only one. Okay? So, you need 2 points to name a line because 2 points determine a line. 2 points make a line. Okay? Otherwise, I don't know which line I'm talking about. I've got all these other lines it could be, right? If it's just 1 point, I'd have all these other lines I could draw through it that I could be talking about. I need to know which specific line do you mean? Which one do you want? If I have points, I know it's this one line that goes through those 2 points and those 2 points only. Well, could be more, I guess. So scratch that last part. But it's the one that goes through those two. Okay? Now, similarly, 3 points determine a plane. Now this one, I might have to do a little bit more with my piece of paper. If I just 1 point sitting out in space, what can I use for a point? Let's just pretend that the end of my expo marker is just 1 point, okay? Floating out in space, and I'm going to put it here, okay? So, how many planes can I put in that on that 1 point? I could do this plane. I could come down on it like that plane. I could come up on it like that plane. There's an infinite number of them again, right, that I could do? Okay. What if I have 2? I'm going to need a volunteer to help me with this one. Anybody want to come on up? All right, come on up. Okay, so if I have 2 points in space, what I need to do is take the 2 expo markers and just do this, okay, and hold them there and don't move them. Okay, so we've got 2 points in space, okay? Here's my 1 plane. Is there a different plane that I could do that goes through those 2 points? Yes. Yeah, right? I could do this, right? I could rotate it, okay? So are 2 points enough for a plane? No. If I do, actually bring them together just a little bit. 2 points, another one here, has to sit flat on the ground. Okay. So I need all 3 to make the right plane that I want, okay? Okay, thank you. So 3 points is why that's why we need 3 points to name a plane. Because if I only have 2 points, Which plane are you talking about? It could be a whole bunch of them. But if I have 3, that locks me into that one plane, and that's it. So that's why whenever we draw planes, it's kind of hard to draw this on notebook paper because it's like 3-dimensional stuff kind of going on there. But there has to be 3 points that lock it in. Like I said, like a tripod, okay? Like if you have a camera. You don't want to use a bipod when you have a camera, right? Because what's going to happen to the camera? It's going to fall over, okay? It's not locked in, okay? But if you have a third leg on that thing, boom, locks it in, okay? So it's sitting on that one specific plane. So that's why that's the case. So lecture, so I'm going to stop recording.